Operations in scientific notation. So scientific notation is just a different way of writing a number, right? So just like regular numbers, we can add, subtract, multiply, and divide. So we're going to look at those 4 basic operations with numbers in scientific notation. Multiplication. So we multiply the numbers in front, right? So in this case, I'm talking about the 4 and the 2. 4 times 2 is 8. Then, so check. Then multiply the powers of 10. Well, we learned how to multiply numbers that have the same base. You just add the exponents. So I'll get 8 times 10 to the 7th. Sometimes it's that simple. The next one that we're going to do, that's our final answer, by the way. The next one that we're going to do has a little bit more work at the end of the problem. So we're going to start off the same. Multiply the numbers out in front. 6 times 3 is 18. I'm going to do it over here so I have enough room. And then we have the powers of 10, right? So to multiply these powers of 10, we add the exponents. Hold on, let me make that into an x. All right. So we get 10 to the 7th, right? So that looks good, right? It's kind of what we did with, it's exactly what we did with the other one. The problem here is that in order for a number to be in scientific notation, it has to start with a number that's bigger than 1, but smaller than 10. 18 is not in that range, right? 18 is larger than 10. So we have to convert 18 into scientific notation. So let's do that. So 18, now if you recall the steps for putting something into scientific notation, step number 1 is place the decimal point so that it's a number between 1 and 10. So I'm going to place that decimal point right here. Then I have to write my number. So I'm going to write 1.8 times 10. And now I have to figure out the exponent. The exponent is how you move the decimal to get it back where it started. So remember, when a number doesn't have a decimal, that means that there actually is one at the end of the number. So if I want to get this decimal point back to where it started, I've got to go 1 place to the right. 1 to the right means my exponent is a 1. So now we're going to write this number in scientific notation. We're going to replace 18 with that. So instead of 18, we're now going to have 1.8 times 10 to the 1st. Now don't forget, we still have this times 10 to the 7th hanging out over here at the end. But we know that when we have 2 powers with the same base, we just add the exponents. So my final answer for this problem is 1.8 times 10 to the 8th. So after you multiply or divide, you always have to make sure that your final answer is also in scientific notation. If it's not, put it in scientific notation and then continue simplifying. Let's look at division. Division is the same sort of thing that we saw with multiplication. We're going to divide the numbers in front and then we'll divide the powers of 10, right? Just like we multiplied the numbers in front and multiplied the powers of 10. So first, let's divide. 7 divided by 2. Well, half of 7. You're probably thinking. If you don't know how to do that one in your head, I'll write out the long division. 2 goes into 7 3 times. Subtract. Bring down. 2 into 10 goes 5 times. And don't forget to bring up that decimal point. So 7 divided by 2 is 3.5. Now we divide our powers of 10. And I'm going to write them in a fraction because it's a little easier to see that way. So I've got 10 to the 4th over 10 to the negative 8. When we divide powers with the same base, we subtract the exponents. So that means I need to do 4 minus negative 8. If you remember from the work that we did with integers, this means the same thing as 4 plus a positive 8, which is 12. So my power of 10 here divided by my power of 10 here is going to be 10 to the 12th. And again, that's because I did 4 minus negative 8. This answer is in scientific notation because 3.5 is larger than 1 but less than 10. All right, how about this one? So I've got 2 and 3. What happens when I do 2 divided by 3? Anyone know what that equals? Well, we know 1 divided by 3 is 0.333333 forever, right? So 2 divided by 3 would be double that. It's 0.66666666666 forever. So I'm going to round it to the hundredths place just to make our writing a little easier. And I'm going to put 0.67. And again, that's, I'll write it over here. That's 2 divided by 3 is 0.6 repeating. So I just rounded. And I'm going to write it as 0.67. Then I'm going to divide my powers of 10, right? And again, I have to do this one minus this one. This time the subtraction problem's a little easier. So 9 minus 4 is 5. So I get times 10 to the 5th. Now we have this issue again of this number not being in scientific notation because 0.67 is smaller than 1, so it's not in that range of being, between 1 and 10, which is what we need. So we have to put it in scientific notation first. So let's do that over here. So 0.67, the first step to putting it in scientific notation is place the decimal so that it's a number from 1 to 10. So I'm going to place my decimal point. I'm going to place it right here, right? So that I have 6.7. Then I have to write times 10, and now I'm going to figure out the exponent, right? That's the setup for scientific notation. To get the exponent, I have to look at how to get the decimal back to where it started. To do that, I'd have to go back 1 to the left. So that means that my exponent is -1. Remember, when writing in scientific notation, it's always, how do I get it back where it started? If you answer that question, how do I get it back? I know where I put it. How do I get it back where it started? That will always give you the exponent for the 10. All right, so now I'm going to replace this with this. So I've got 6.7 times 10 to the -1, right? And then I'm going to bring this part down times 10 to the 5th. So 6.7 times, and I'm going to add, right? I'm multiplying with the same base, so I add the exponents, 10 to the 4th. -1 plus 5 is 4. And that is my final answer for that one. All right, so that's multiplication and division. Now let's look at addition and subtraction. Now addition and subtraction are similar, same steps for both. But here's the key. In order to add or subtract numbers in scientific notation, they have to have the same power of 10. Once you've got the same power of 10, easy, right? But you have to get the same power of 10 first. So let's do it. So I see that I have 10 to the 5th and I have 10 to the 3rd. So I'm always going to change the smaller one to be bigger, and I'm going to show you how I'm going to do that. Actually, I take that back. I'm going to change the bigger one to match the smaller one. So that means I'm going to work a little bit with this number first, right? So I know that I'm going to keep that 2.73 for now, and I know that I want to multiply by 10 to the something times 10 to the 3rd, right? And I know this looks weird, but what I'm doing is I'm breaking up the 5 into two numbers that add to 5. I want one of them to be 3 because of this 3 over here, right? I have to match it. So what number can I add to 3 to make 5? I can add 2, right? 2 plus 3 is 5. So whereas I had those two powers of 10 and I was simplifying in the last two problems, here I have the one power of 10 and I'm breaking it up. Now I'm going to write this part in standard form. So if I'm multiplying by 10 to the 2nd, that positive 2 means that I need to move my decimal point 2 places to the right. So I'm going to get 273 from this part. Okay? Then I write the rest of my number. So that's times 10 to the 3rd. Now I'm adding 1.8 times 10 to the 3rd. Now for this part, I'm going to do just regular decimal addition, right? So I'll do it up here off in the upper right hand corner. So 273, remember there's a decimal right there. If I'm going to add 1.8 to that, I have to line up my decimal points when I add or subtract. I'll get 8, bring down the decimal, 4, 7, 2. Right? So this is the number that I get when I add this and this. So now I have 274.8 times 10 to the 3rd. You just keep the power of 10 the same, right? That's what it says over here too, if you forget. Keep the power of 10. We add or subtract the number in front and keep the power of 10 once they're the same, right? Okay. Here we go again with a number that's not in scientific notation, and we have to put it in scientific notation. So I'll do that over here off to the side. So I've got 274.8. I want this to be in scientific notation. Step number 1, write it so that it's a number from 1 to 10. You're probably getting so used to these steps, I hope. So if I make it a number from 1 to 10, I would put the decimal point right there, right? So that would be 2.748. Then you write times 10. And now to figure out your exponent, you've got to see, how do I get it back where it started? Here's where I put it. To get it back where it started, I would have to go 1, 2 to the right. So this is a positive 2. All right? Hopefully you're with me so far. Now I'm going to replace this number with this number. And I have 2.748 748 times 10 to the second, right? That's my whole number that I just got. But it's also times 10 to the third, because I have to also bring that part down. When we multiply with the same base, we add the exponents. So my final answer, this part stays like that. And then I have times 10 to the fifth. Step by step, just follow the process step by step. Let's look at a subtraction problem. All right, so again, we have to get the numbers written with the same power of 10. So I'm going to rewrite the larger one so that it's the smaller one plus something else, right, in the exponent. So let's do it. I'm going to take this one and I'm going to rewrite it as 7 times 10 to the something times 10 to the fourth, right? Because I know that I want one of the powers of 10 to be 10 to the fourth. So now I need to think 10 plus what is going to equal 5? Well, it's kind of easy, right? Not 10, sorry. 4 plus what is going to equal 5? Well, I'm going to have to fill this in with a 1, right? And 10 to the first is 10. Yeah? So if I do 7 times 10, I would get 70 times 10 to the fourth. Then I can subtract this part. So I'm going to do the subtraction up here. 70, there's a point there at the end, minus 5.2. I'm going to have to add another 0, and I'm going to have to do quite a bit of borrowing. So borrow from the 7 and make it a 6. This becomes a 10. Borrow from this 10, make it a 9, and this becomes a 10. 10 minus 2 is 8. 9 minus 5 is 4. Oh, don't forget about that decimal. And then bring down the 6. So now after doing the subtraction, right, these two numbers, I get 64.8. And now I keep my power of 10 times 10 to the fourth. Here we go again. 64.8 is not in scientific notation, right? It's not between 1 and 10. So let's put it in scientific notation. I've got 64.8, and I want to first place the decimal point so that it's a number from 1 to 10. So that's going to be 6.48, right? So that means I'm moving the decimal point right here. Then I'm going to write times 10, and now I need the exponent. To get the exponent, here's where I placed the decimal, and I have to look at how to get it back where it started. To do that, I move it 1 to the right, so my exponent is 1. Now I'm going to replace this with what I just got. So that's going to be 6.48 times 10 to the first, right? And I still have to bring this down, times 10 to the fourth. So altogether, I would have 6.48, sorry, I'm running out of room down here, times 10 to the fifth. So that would be my final answer for that one. All right, so multiplying and dividing, you don't have to worry about them being the same power of 10. You just multiply or divide, right? Your numbers and your powers of 10, And then you just have to worry about the number being in scientific notation. So those are actually easier. Addition and subtraction, on the other hand, you have to have your powers of 10 be the same. So you're going to have to rewrite to get them in the same power of 10, then do the addition and subtraction, and then rewrite again to make sure your answer's in scientific notation. So this is a case where addition and subtraction is a little more work than multiplication and division.